Today, Bambu Lab are releasing another machine, the H2S. This is basically the H2D, but with an A1 style single nozzle tool head, but with their servo extruder motor, and it prints even faster with a large build volume. For those that wanted an X1C with the large build volume, this is it. This is the printer. The thing is, I normally do teardowns of new machines to show you what's inside, how they work, and things that you might find interesting. But because this machine is basically identical to an H2D, barring the tool head, I don't think it's worth it for me to tear down the entire machine because most of the video would just be a copy and paste. And I think every other reviewer will cover things like print speeds and Hotends, blah, 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 so I'm going to do something different. When I published the H2D teardown, I was surprised by how many people commented that the design looked overcomplicated and impossible to do maintenance. So today, on the new H2S, I'm going to test a variety of maintenance operations and see how long they take, how well planned the design is for those operations, and give you some general thoughts and tips on doing maintenance on the H2S. Now, I know this doesn't necessarily directly address the concerns or questions of the H2D's complex toolhead, but nevertheless, to save raising more questions on a new printer, I thought I'd test maintenance on this one. In the interest of disclosure, Bambu Lab provided me the H2S as an early tester, but they didn't stipulate any conditions or encourage any sort of content in any particular way. I've not been paid to do the video, but of course I do now own another 3D printer. Obviously, it's impossible for me to test every single maintenance operation, so I'm going to focus on just a few tests. This video is not sponsored by any external company, but it is supported by my own shop, vector3d.shop, so if you're grateful for what I've done here, want to see more like it, or just interested in some cool 3D printing gear, please consider supporting by grabbing something from the shop today. The first test is filament sensor replacement. The guide suggests 20 minutes and a 1.5 and 2mm hex as the tools required. I started the timer after I had the printer on a workbench, unplugged, and I'd looked through the instructions, so there is a little bit of prep in that kind of pre-timer stage. Completion of the actual task took me just under 6 minutes. Most of that time was trying to get the ribbon cable back in, so my top tip for this process is to stand at the back of the printer. You get much better visibility and access, making the process, specifically with the ribbon cables, that little bit easier. There is one potential risk with this procedure, and that is dropping the M1.5 screw down into the extruder. I almost did it twice, but got lucky and just about missed. It's stainless steel, so it doesn't hold onto the driver magnetically, and the thin profile hex means it doesn't sort of physically sit on the driver very well either. So just be careful when you do that, because if you drop it in, you're going to have a hell of a job getting it out again. The replacement comes with a cable if you need it, but it's unlikely to fail unless you went full gorilla mode during the removal, as it's quite a simple process. From a design perspective, I'd definitely say that this replacement process was considered during the design phase, given that you have pretty much direct access to this replacement without affecting anything else. Next was the filament cutter replacement. This is a small blade that sits in the tool head that cuts the filament between where it's feeding and the hot end. You may need to do this process fairly regularly, as it suggests every 10 to 15 rolls of filament or every 5 to 7,000 filament cuts. The guide suggests 5 minutes and a 2mm hex with optionally some tweezers in order to complete the job. The obvious risk here is cutting yourself with the blade, which is very sharp, and I nearly did do that while trying to place it back into the holder. So my top tip for this one is hold the blade front and back, not on the sides. That will give you the best leverage to press it into place without the risk of slipping and cutting yourself. Overall, the blade replacement took literally 2 minutes to complete. Again, there's clear consideration for maintenance here. There are holes within the parts here that give you access to screws that you wouldn't put in if you weren't trying to do this maintenance job quickly. The blades themselves are the same ones used in other machines by Bambu Lab, so overall, a well-considered operation that's cheap and easy to do. Now we'll move on to some more complex operations, and these will start with the same part cooling fan and rear cover removal. So that's what I'm doing now, and then I can use this as a reference time that I can add to the other maintenance operations to get a total time. I also decided to add in the hot end removal here, so it's just removal of the front cover, removal of the sock, undoing the clip, and pulling the hot end out the front. It doesn't add very much time, but I think it's useful for most of these operations, so worth considering. Next, I'll replace the hot end heater assembly, which is the clamp, heater, and thermistor, which you can see behind the hot end when you switch them over. The guide suggests a 1.5 and 2mm hex, as well as 25 minutes of time to complete the task. All you have to do is undo some connectors, fish out the wires, and unscrew the assembly. Quite easy, just to say, but less easy to actually do. I would highly recommend the use of tweezers as suggested in the manual. In fact, I'd quite like to see something included in the box with the machine. My top tip for this process is that when you reinstall the hot end, get the cables into that small clip channel before screwing the heater into position. I found this the fiddliest of the processes done so far. The cable clip that holds the wires for the hot end and fan is really stiff, and there just isn't much room to insert the wires. If it was a little bit more flexible, or the gap was just a fraction larger, I think that would really help. As it was, I did feel quite close to damaging the thermistor cables in particular on the hot end. That being said, I have completed the task without any damage, so it's definitely possible. The total time to complete this job was around 20 minutes, 5 less than stated. But I did feel my stress levels rise with the cable guide situation, so that's worth keeping in mind too. Whilst this process is a little bit more complicated than the others, I think there's still clear consideration for maintenance. For example, all the hot end screws come in directly from the front. If one was from behind or from the sides, then there'd be additional difficulty, whereas just all from the front makes it really easy to actually access the hot end without removing the fan or the extruder or anything else. Next is the extruder unit replacement. This assembly includes an extruder plate, gears, motor, and the filament sensor which we replaced earlier. The guide suggests 30 minutes to do this. You have to remove the rear toolhead panel again, as I stated at the start, then partially remove the toolhead board to release 3 rimmer cables, unscrew the assembly from the front, carefully guide out the ribbon cables, and then the whole process again in reverse. Unfortunately, I did get in a bit of a pickle with the removal, as one of the cables was taped to the inside of the extruder housing. Presumably this is to prevent vibration and noise and stuff and just make sure it doesn't go to places it shouldn't be in. But I didn't see it. The instructions, whilst they kind of suggested something might get caught, I didn't quite expect it to be actually stuck on, and basically the cable snapped as I pulled it out. Fortunately, the spare unit does actually come with replacement ribbon cables. However, I have no spares, so I'm just taping it up and putting it back, but I can't use it, obviously, now as it is. I did mention this issue to Bambu Lab, who quickly investigated it and have made some updates and changes to the instructions in order to better guide you through the process. I also have some spare parts on the way, but I think they're unlikely to arrive until after I finish the video. In total, this process took me the full 30 minutes as the guide suggested. It's definitely quite a fiddly one, and evidently the most difficult so far, seeing as I accidentally broke something. The final job I'm going to try here is the TH board, or toolhead board replacement. This is the PCB which you've seen a few times already. It sits behind the toolhead and is responsible for basically all the electronics and motion and stuff within the toolhead. Due to its broad spectrum of functionality, there are obviously a number of reasons why you might need to replace it, but I wouldn't expect any of these to be common. The guide suggests 20 minutes to do this and just a 1.5mm hex. The bulk of the operation here is just dealing with small electrical connectors of various shapes and sizes. Those with bigger fingers and hands will definitely benefit from tweezers, at least with plastic tips if possible, to reduce any damage and risk to the cables and stuff. Overall, it took me 19 minutes to complete the job, although it's worth noting I didn't have to do the heat spreader replacement, which does involve dealing with thermal paste, so that could probably take you an extra 5 minutes easily. When it comes to trying to evaluate the design of the toolhead replacement procedure, I think we do have to consider how often it's expected to be done. I think for most printers, you might even never do this. And so any compromise in the design in order to optimize the speed of this process is probably considered not worthwhile. Let's say, for example, instead of 20 minutes, you can do it in 15 minutes because we've improved that process. However, as the compromise, we've had to increase the size of the toolhead and therefore you lost 10mm of build volume on both X and Y. I'm not sure that's a compromise many people would be willing to make, and therefore we end up with the process that takes 20 minutes. So this was my first time trying out and testing a machine purely from a maintenance perspective. Let me know what you think and what I can improve on. Thanks very much for watching, and I'll see you in the next one.